Welcome back, everyone, to this session. The session will be about Slurm. You might not know what Slurm is, but by the end of the session, I can guarantee that you do know. And until now, you've learned how to access the clusters. You've learned how to copy data back and forth. You've learned how to choose the software or to compile software with the modules. You have also learned how to create and write text files. There's something that you still haven't learned is how to actually use the power of the cluster and run jobs on the clusters. The short answer is that you do not run something on the front end, just like you would do on a regular Linux machine. What you will do is submit a job to the resource manager or job scheduler. So this is the answer to the question, and all the slides afterwards will explain this sentence. And we'll start with a job. So if you look into the dictionary and look for job in the context of computing, a job is an operation or a set of operations grouped together, treated as a single and distinct unit. So actually you get to decide what a job is. It might be running some program on some data or running another program to produce some data. It all depends on what you are trying to do. And that job will be submitted to a job scheduler, which is a piece of software that runs on the cluster that controls everything in the cluster, basically. It's called either job scheduler or resource manager because it actually has two purposes, but the main one is to give out resources to jobs. What are resources? A cluster is made of compute nodes. This is what a compute node could look like. We call them those form factors pizza boxes. And so a cluster is a set of all those compute nodes. And inside it, you have multiple items, such as disks, like you would have in a regular computer. You have the motherboard on which you can find some memory, some CPUs. And inside the CPUs, you have cores, which are all the single compute units part of a CPU. And then maybe in some compute nodes, you will have GPUs, so graphical processing units that can accelerate some of your jobs. The idea with those resources is that the job scheduler will organize the job around those resources. So if you create a graph with the time here and the resources here in an abstract way, you can view a job as a square because it uses some resources over time. And so if you look over the time, you have a job here, you have here a job that is completed. If the no line is here, this job is complete. Those two jobs are running, so they are in the process of computing. These jobs are pending, so Slurm, the software, has decided that they would start next, but they are not running yet. You will have to wait for no to reach here for them to begin running. And then you have submitted jobs, which are depicted in green here. And the goal of the resource manager is to find a place for those jobs based on the resources that we have, which are not infinite. So in a sense, it's a bit like playing Tetris. I don't know if you know what Tetris is. Maybe you're too young. So this is Tetris. Okay. Tetris is old game running on a Game Boy. Jérôme talked about how Vim was old earlier, and this is even probably older. Anyway, so basically, the role of the scheduler is to allocate exclusive resources to jobs over time. And the name of the software that does that here is Slurm. So Slurm is free, so you don't have to pay for it, and you have the source, access to the source. It's mature. It's been existing since more than 20 years, or a bit less than 10 years. There's a very active community. A lot of people use Slurm. There's a lot of success stories, and also it's the name of an intergalactic soft drink. So the developer, they claim that was not for that they chose the name, but anyway, that's a truth. So today, what I will be talking about is first how to create a job, and how to submit it to the scheduler. I will explain also how to choose the resources, because you will see that in the job, you will need to specify the resources that you want. And I will explain how you can decide which resources to request to the scheduler. We will talk about priorities, because often users, what they want to know is why my job is not running. The answer is because your priority is not high enough, and they're not happy with that single answer. So here I will explain everything, how it goes around the notion of priorities. I will explain how to create job script for typical workloads, single process, multi-process, multi-nodes, and so on. I will show basic workflows. Sometimes you have jobs that depends on other jobs or that are very similar to each other, and there are ways to manage that easily in a single way. We'll talk about interactive sessions, because we will see that basically the cluster works in batch mode, meaning you describe a job, you submit a job, you go get a coffee or do something more interesting, and then you come back and have access to the output of your job. But you don't get to see your job running in real time, except if you ask for an interactive session. And we will see how to do that in the slides. Afterwards, if I have enough time, I will show you a workflow management system, which is another way to submit jobs, which is a bit more interesting in terms of not having to learn the intrinsics of Slurm, but you will just have to describe in a more easy, user-friendly way your job. But that will only be if I have sufficient time. So about the first part, I will show you how to create, submit a job, monitor it, and cancel it. So to create a job, you first need to make up your mind. As I said earlier, you need to decide what operations you want to perform, and that depends on the goals that you have with your research. And you have to decide the resources that you need for those operations. So for instance, you need one CPU core with 2 GB of memory for 10 minutes. You need to know that in advance to be able to tell the scheduler that this is a set of resources that you need, so that the scheduler can find a spot in the scheduling plane where your job can be put. Once you know all about that, what you can do is write a submission script. So a submission script is a script in the Linux sense or in the Bash sense. So it's a set of operations written in a text file. And here is an example, a typical example, where you can find the first line is typical of Bash scripts. So it actually indicates to Linux that this a script is a Bash script that you can execute, but we will not execute it, you will see. And then here are comments. So you know that in a Bash script, there are, you can put comments that do something, but you can also put comments that give information about the code, but are not used at all by the system. Except that if the command starts with "-", Slurm will look into it and try to find information for him. So here, an example is that if I put "-" job name equals demo, then this is a way to instruct Slurm to create a job that will be called demo. So the name is only for you to refer to, but it's a way to organize the jobs in the end. And then you have operations. You can put simple operation, Bash operations that you learn in the Linux command line session. And also you can create job steps with the srun command. So the srun command is part of Slurm, and it's a utility that will help you create job steps. And actually in the single submission file, you can have multiple job steps if your program or the problem you want to solve has multiple steps. You can start each of them in the same job. But if you start with them with srun, Slurm will be aware that these are distinct job steps. And in the accounting that we will see later on, when Slurm will tell you what happened on the cluster when your program ran, you will have information line by line for each of your job steps. And so this is a simple echo command. Once you have a job script like this, you just to make sure that there are no Bash variables here, because actually Bash sees this purely as commands, so it will not try to interfere whatsoever with what is written there. So if you put their bash variables, bash will not expand them. And also you must make sure to have this block as a whole and not have commands like this inside this block, because as soon as Slurm sees here a command like this, it ignores everything that was meant for him afterwards. So it's a typical error that people request 10 nodes and they realize their job run on one node only. Often it's just because they put here and echo something and then Slurm ignore everything there. Once you have your submission script, you use the sbatch command. Sbatch and the name of the script. You can put additional options here. So here you see -- partition. I will explain later on what a partition is. It's another parameter that I add to the job, which was not in the submission script. But I could have put -- partition equal open in the submission script. It will be equivalent. And actually, there's a third way to give options to Slurm about a script is through environment variables. So we will see many options that you can use to describe the job or to tune the job. And the options can be given to sbatch either through the command line, like here, through the job submission script, like the slide before, or through environment variables. And Slurm takes them in this order. So if you put -- partition in the submission script and also on the command line, is the one on the command line that wins. Okay, most of the time it's easy if you have a typical submission script and then you want to change one bit just for a test, rather than changing the script, you can add the parameter on the command line. And then, very importantly, Slurm gives you a job ID. So it's a big number, a large number that references the job that you will use afterwards to query the status of the job, cancel the job, and so on. Okay, what is clear enough? So you just need to write a text file with some characters in there, decide what you want to do and how much memory, cores, and so on you want to consume. And then you put everything in the file and you use sbatch. So I suggest you try to do that. Connecting to any cluster you want, they all run Slurm in the CÉCI. You can open a text editor, and if you don't know which text editor you choose, yes? We'll see a lot of examples afterwards. So here, I'm only showing you how to use one CPU of one machine at a time, so that we get everything squared. And then we'll see how to make parallel jobs that use multiple cores on multiple nodes. And you will see that Slurm will allow you to choose exactly the distribution of cores on nodes and the distribution of tasks also. I hope this will become clearer in 1 hour. So you can try to write a submission script that will be very simple. It will look like the one that I've shown on the screen earlier, and then use sbatch to submit the job. And then you can look for files that will be created in your directory. Because I did not mention it further, but here you have a -- output parameter, and then the name of a file. And this is a file where Slurm will put the output of the program. So normally, when you are connected with SSH on a Linux machine and you type a command, you see the output of the command, the standard output and the standard arrow in the terminal where you are working. But here, since the job will be running on a remote computer where you have no terminal, what Slurm will do is capture all this output and put it in a file. And the name of that file is chosen here. If you do not specify a file name, Slurm will just choose one for you. It will be slurm - and then the job ID. So when your job is finished, this file will be created in your home directory with the results. So actually, the file will be created as soon as the job starts, and it will be populated on the fly, but by what your program will be doing. Yes? So the first line is mandatory? So the first line is mandatory if you want a bash script. So every example here will be about bash. so the standard shell on Linux machines. But if you want to have ZSH, Python, Perl, anything that is a shell in Linux can be used as a submission script. If you don't understand my sentence, yes, you need to write bash here. Sorry? So here is the maximum time that your job will be allowed to run for. So it's a very important parameter that you need to give to Slurm is how long you expect your job to run. And this is used, and I will show examples later on. This is used by Slurm to schedule and organize the jobs. Many slides to come. I hope you will have all. If I didn't answer that question in 1 hour, ask it again. Yes? Yes. Often it's easier to have them one by line because you can comment them. So the start of the line must be exactly this. So if you have a space here or a second hashtag sign, it will be ignored. So it's a way also if you have an sbatch parameter here, but you actually don't want to use it, you can put a second sign like this here. Okay, so basically what I was saying is that if you don't know which editor to choose, you've had a session about Vim before, so you can try to find your way around with Vim. Otherwise, there's Nano also, or gedit, or whatever editor you prefer. So try to submit a job. First, write a submission script, and then submit the job. I can try to do it as well. So I'm connected to Lemaitre 3. I will open Vim. And then actually a submission script can be as simple as this. Okay, so this is a valid submission script, but I don't specify any resource. So what I get is the default resources. So typically we were talking about the time. I will get the maximum allowed time on the cluster. Number of CPUs will be 1, memory will be 1 GB, depending on the limits that are set on the cluster. So if you want to be lazy, you can. Otherwise, you can do something like this as batch the dash time equals, and then this would be 10 minutes.
We don't see.
Sorry, like this. Okay. So it was like this, and I said, okay, I can add this, and this is a parameter that says, okay, I want to request my job to run for maximum 10 minutes. So you see the file here. You see the mess that I did before. Sometimes it happens. And so I can run sbatch and then the name of the submission file. And Slurm tells me that he has taken the batch job and assigned it this number. Okay. So it's just like in the slides. If I look into the directory, I can see that my job has been running actually. Sorry. Because here I see a Slurm dash and then the job ID dash out. And if I look into it, you will see the result of the hostname command. Okay, so the goal of the program was just to write the name of the host on which it ran. And you see that this is one of the compute nodes. So on that cluster, we have a bit less than 80 nodes. And it was on the last one that the job ran. Okay, was everyone able to submit their first job, or maybe it was not your first job, but okay, so until now, very easy. You create a text file, you put in there the commands that you want to run, and you put a definition of the resources that you want, and then you use sbatch, and you're good. Now, you might be wondering what is happening to your job as soon as you hit the sbatch command, and actually it will be entering a queue. And you will be able to see the contents of the queue with the sq command. So you maybe notice that you use the sbatch command, and here we have sq, and you will see that all the Slurm commands start with s. So if you have a command that starts with s, most probably it will be related to Slurm. So sq is a command that allows you to see the waiting queue, or the jobs that are waiting, running, or pending, which is the same as waiting. So you can try to run sq on a cluster, and you will see an output like this. So sq, enter, and then you have some columns here, which I will explain a bit in detail. So the first is a job ID. As I said earlier, as soon as you submit a job, you get in return a job ID, and this is the handle that you can use to actually act or get information about your job. Second is a partition. A cluster is a set of compute nodes, and compute nodes can be grouped logically into partitions. So here you see that there are two partitions. One is named batch, and the other one is called debug. So typically, when you have a debug partition, it means a partition with a smaller amount of nodes, but a very high throughput where you can test actually jobs very easily. Sometimes when you submit a job, you need to wait for a long time if the resources are not there, or if your priority is not high enough. And so if you have tests that you want to do, most clusters have a special partitions where tests are easy to do. So if you see partition testing or debug, you can try to submit jobs to that partition, and you will not be able to submit large jobs, but the jobs that you submit there will start sooner than if you submit it into the main partition, most of the time. Here you see the column is the name that we chose for the submission script for the job. It was indicated by --job-name in the submission script. And then the user is the login. So DFR is me, VVR is Barbara. And then ST is a state. So here you see mainly two states, and you will most of the time see only two states, running and pending. And when the job is running, you will be happy. When the job is pending, you will not be happy. I know that already. Then you see nodes, time. So this is the time that the job has been running. So this column holds relevant information only for running jobs. So you see that the two jobs that are in pending state have no information about time. But as soon as they will start running, that column will show the time for which they've been running. And then the column after is nodes, is the number of nodes that were allocated to each job. And then the last column is the node lists. So it's the lists of the names of the nodes that were allocated to the job. So the first one has been allocated nodes 1 to 4, and the last one nodes 5. And you see that for jobs that are pending, they have not been allocated any nodes, sorry. So otherwise they would be running. But then what you see is between parentheses, the reason why they are pending. And the main two reasons are either resources, meaning that your job is the most priority one, and as soon as resources are available, it will start. Or the other main reason is priority, which means that there are other jobs with a higher priority than yours in the queue, and they will start before yours. So this is the typical output that you get from SQ if you just type SQ in the prompt when you're connected to a cluster.
So there are some parameters that can do to try it out.
You can submit a job by yourself.
Yeah, what jobs? There's some example job or something.
Just as name as if you want the job to last a bit longer, then you can use a sleep command in the submission script. So you create a file, you type sleep 300 in there, and then submit as batch with as batch the name of the file, and you will see it enter the queue. I can do it like here if you want. Okay, so if I take my so hostname is a very fast operation, so it does not last for long, but I put here the sleep command, and I can again as batch it. And then with SQ, I'm anticipating a bit, but actually you can filter the output of SQ to show only your jobs. And so if I type SQ -- me, you see that the job that I just submitted is in the running state. In the running state, it's been running for 13 seconds. So if I run it again, you see the time here increases. And again, just like before, I was given the same node. Okay, so this is what I showed. SQ gives you a table, and actually you can filter the lines of the table, and you can also choose the columns. So here you see that I'm filtering the output of SQ to only show my jobs with -- me, but I'm also using -- start, which is a way to ask SQ to not show the default information, but show information about the expected start time of the job. So while a job is pending, Slurm will try to find resources. And as soon as Slurm knows that at some point in the future, the resources will be available, it will set the departure time or the start time of the job, and it will give you the information here with the start time column. And -- start is actually a way to choose the columns so that the start time appear. You can also choose any columns you want actually with the -- format option. So with the -- format option, you give here the name of the column that you want to display, and then Slurm will show you the information that you want. So you can actually tailor the output of SQ to your liking, depending on the information you want to see. And you see here also -- partition equals debug. It's another way to filter. It's different than saying I want all my jobs. Here I say I want all the jobs that are submitted to the debug partition. Any question about that? So SQ gives you the output of the queue. If you want to know everything about a job that Slurm knows about, you can use the scontrol show and then job ID command. And it will give you this output, which is basically everything that Slurm knows about your job. So everything that you decided and everything that Slurm decided for you based on the default if you did not specify it. And also everything that Slurm has computed about your job. If you want to know exactly all of this, you can type man scontrol and you will see the man page of the scontrol command. Okay, let's assume now that you want to cancel your job. Maybe you did a typo or you made a mistake. Just like before, it's a Slurm command, so it starts with an S. And you want to cancel, so it's called scancel. And scancel takes a job ID. So you see here a fictitious queue where there are two jobs. One of them has ID 10324. Scancel that job ID, and afterwards you see that it has disappeared. Okay, so very easy to understand. Just like with SQ, you have multiple options here to filter jobs. You're not forced to give a job ID. You can say all of my jobs, or all of my jobs that are pending, or all of my jobs that are in such partition. You don't need to list every job ID by yourself. You can just use the parameters here to choose exactly which jobs you want to cancel. If you realize that you made a mistake, but you don't want to cancel it and the job has not started yet, you can modify it with scontrol. So as controller date, you give it the job ID and then parameter equals value, and you can change a parameter that you set in the submission script or by an environment variable or by the command line to something different. So you see here two jobs, and one of the jobs, which has this ID, requested 2 nodes. And then I realized afterwards that I actually wanted 3 nodes. I can change with as controller date job ID equals the job ID, and then num nodes equals 3. And then when I run SQ again, you see that the parameter was updated. There are a few parameters that you cannot modify, even if the job is pending, and most of them cannot be modified when the job is running. And most importantly, you cannot try to extend the maximum time or to get larger resources with scontrol as soon as the job is running. Any question about this? So you create a text file, you put some commands, you put some parameters, you use sbatch to submit it, you use SQ to see what's happening, and you look into the directory for the files that are created by sbatch about your jobs. Yes?
Assuming that they place time for an unusual job, if you modify it by requiring like just more time, you will get to the end of the queue again.
It depends on the configuration of the cluster. What might happen is that your job starts sooner, and then we see why. But it's all a question of priority and backfill. And you will see that if you shorten the job, you have higher chances of being backfilled. And I will explain what the backfill is. But basically, the order in the queue is decided on the priority, and the priority has multiple factors. And so it depends if you change a feature of the job that is impacting the priority or not. So sometimes the priority depends on the job size. So if you increase the job size, you get more priority. So you might climb up the queue. So the answer is not yes, no, it depends. And most of the time, when you have a question, my answer will be it depends. I will try to explain a bit more why it depends, but there are many, many options in Slurm that you or the system administrators can queue. So the second part would be about discovering the resources that the cluster offers. Because I said that you can use parameters in a job description script to choose the resources that you want, but if you don't know what the resources the cluster can offer, you're a bit stuck. So if you need information about the cluster, there's a Slurm command that is called sinfo. Start with an S and it provides information, so it's sinfo. If you run the sinfo command, depending on the cluster, you will see something like this. If you do this on Lemaitre 3, you will see something different because we've tried to make it a bit more informative and prettier to the eye. But this is a default output. You see a description of partition, node list. So node lists is exactly as in the SQ command. It's a set of nodes that are part of this partition and that are in this state. So the states can be idle, alloc, or mix. These are the 3 main states that you will see. They refer to nodes. So a node is idle when no job is running on it. So it's either not doing anything or being reserved for a job that should start later on. Alloc or allocated means that the node is full with jobs. So all the compute resources that it offers have been or are used by a job, and we cannot allocate more resources from that node to any job. And mix is in between, meaning that some resources are used and some others are still available. You see here the time limit column. It indicates the maximum time that your job can run on the cluster. I said earlier that you need to specify a maximum time for the job, but you will not be able to specify that your job will run for 3 months. On Lemaitre 3, for instance, the maximum is 2 days. On NIC 5, the same. On Dragon 2, it's a bit longer. And actually, the longer the queue, the longer the maximum time on the cluster, the longer the waiting time also. So when the maximum time is short, the jobs can run, can turn over rapidly. When the work time is long, you can have jobs that use a cluster for 2 or 3 weeks and all the others are waiting. So depending on the resources, we also try to have the maximum running time the shorter possible. And the session after this one, which is called checkpointing, explains how to deal with a short running time when your program needs to run for longer than the maximum allowed time on the cluster. So this is the basic output of sinfo, but as I said, if I run sinfo on Lemaitre 3, you see it's a bit different. This is a part about the partitions, as I explained before. You see here a list of partitions with the maximum runtime, and we also give information about the file system, but the file system is a topic of a completely different session. If you want to know, by the way, if you want to know if sinfo gives you the basic output or something tailored, you can use type sinfo. And then here you see that sinfo is actually a bash command. But if you run the same command on NIC file, you will see that sinfo is /bin/sinfo, so it's the basic sinfo. Any question about those sinfo? No, so just like other Slurm command, you can choose the columns. You see here the -- format option, which allows you to choose the columns. And if you have been writing code in C or C++ or many of the other language that know about format string, this is a typical format string. So the letter corresponds to the name of a column, and the number here is the width of the columns. And basically, if you -- format, and then you can write a format string that allows you to choose exactly what information SQ is showing. So now you know how to discover the parameters. Basically, I need to explain about this important. So here you see I've chosen to display number of node partitions and then available features. And the features are characteristics of the nodes that the admin labeled the nodes with. So here you see that in the batch partition, we have all compute nodes that have actually they all have the same CPU, but this is a way to characterize the CPU, so the processor that is in the cluster. So if you are in a cluster when there are multiple different versions of CPUs, so maybe different vendors like Intel or AMD, or different generations of CPUs, most of the time the admins will have set up features like this to be to enable you to actually choose the CPU that you want. Sometimes some program only run correctly on old CPUs or run very fastly on newer CPU. Sometimes you want to choose. This is the way to do it. It's through the features. You see here, n CPUs is the number of CPUs that the node offers to the cluster. So here 64, meaning that there are 64 one CPU job that can run at the same time on that machine, or one job that uses 64 CPUs. And then you see the memory, so the RAM, the random access memory, the memory, the working memory in megabytes. And then here you see GRS is a generic resource. So it's anything that is not memory or CPU, but most of the time what you will find in the GRS command is a GPU. We have multiple sessions later on about GPUs, but basically what you need to know about GPUs, if you don't already, is a piece of hardware that allows to accelerate the computations. And GPUs have a type. Here the type is set to the name of the GPU, it's a Tesla A100. And the last column, the last number after the column is the number of GPUs. So these are the features, the GRS, the CPUs, and memory. These are the resources that you can request for your job. And you request them with specific parameters. So if you want a specific feature that we saw in the column previously, you can use -- constraint in your submission script. So if you want, say, a ROM, so these are distinct way to describe the CPU. This is the vendor, this is the family, this is the name of the stock keeping unit, as you call it, and this is the generation. Basically, I'm summarizing. If you don't know what it is, it means that you don't need to use them. But if you know what they are, you can choose exactly what you want. And you can choose with the -- constraint option. So in a submission script, you write hashtag sbatch -- constraint equals, and then let's say ROM, for instance. And then you know that your job will only start on a ROM CPU. If you need a GPU, or any other generic resources, but mostly on the CÉCI cluster, the generic resources will be GPUs. You use -- GRS or -- GPU, and this will tell Slurm that your job needs a GPU to start. And if you are on a cluster that has no GPU, your job will never start, or it will be rejected by Slurm at submit time. Some clusters also have some licenses defined, so you can sometimes have software that runs only through a token that must be acquired from a licensed server. And this is organized by the -- license option. We don't have clusters that run like this on the CÉCI. You can choose a partition with that partition. You can specify a QoS. So if you see in some documentation information about QoSs, QoS is a quality of service. So it's something that you can add to your job to change its priority oftentimes, or actually to use a different quality of service. So typically we use quality of service to give a priority boost to a job, but only allow it to run for a shorter time, for instance. So you get something, but you lose something else. This typically is how we use QoS. If you don't have access to a QoS, it's pity, but if you do have access to a QoS, and it's defined by the administrators based on resources that you provide, or so on. For instance, here in Louvain, we have a Manbach cluster, which is a cluster not part of CÉCI, but built with funding from different parts of the university. So some parts in the university have a specific quality of service that allow them to run faster on the hardware that they paid for. And then you will see that with -- nodes, -- and task per node, CPU per task, you will be able to choose actually the number of CPUs that you want, number of compute units that you need for your job. I will show plenty of examples with those, so I will not spend too much time on it now. There are other parameters, such as job name. You've seen it already. You can also attach a command to your job. It's purely for the user. If you need to remember something about the job, you can write it here, and it will be in the accounting as well. So when your job is finished 3 or 4 months ago, later on, you can use the information that you put here to remember about your job. Yes. So a partition is a set of nodes in the cluster. So the cluster is a set of compute nodes that are stacked vertically, basically, and they are organized logically into partitions. The reason for creating partitions is either to create a set of nodes with specific access policies, or to group together a set of nodes with the same hardware. So typically on the Metro 3, you have a batch partition and a debug partition. In the batch partition, you have 80 nodes with a Skylake CPU. And in the debug partition, you have 4 nodes with a Haswell CPU. And the maximum running time on the debug partition is much shorter. So there's a difference in policy, the maximum allowable time. And in terms of physical hardware, you have a more recent generation of CPUs in the batch partition and older CPUs in the debug partition. some clusters have specific partitions for GPUs, for instance. And so you might find the output of sinfo showing a GPU partition. It means that all the nodes that have GPUs are grouped into that partition. Any other question? Yes?
On the website, does it say, for example, for a given node, let's say, and then for a given partition, does it say, for instance, how much the maximum, how long the maximum time is allowed?
So the maximum time is per partition, and you can have the info by sinfo. And the website, the CÉCI website, I think has a column in the clusters tab that shows the maximum time, but I'm not sure it's up to date all the time. So the best way is to ask the cluster.
In partitions?
Yes, per partition. I think the information is for so sinfo shows you the information. Here you see the information per partition. So batch is today, debug is 6 minutes, and I think the website also has information by partition. But the best way is to run sinfo here. And if you follow all these sessions, in other session, I will show you how to run the sinfo or all the clusters at the same time. So you don't have to log in, run sinfo, and go to another one with a cluster shell too. It's another session. Yes?
In sinfo, on the availability, we have our own apps, and there's some color coding. I'm checking for the new, but I don't find it. So there's some apps are coding new. So now,
I don't know either. So the avail is the availability of the partition. So it's either up or down, depending on whether you can submit jobs or not. Most of the time you will see that they are up, but the color codes.
debug partitions which are available at the app is written in green.
On which cluster?
Dragon.
So when you type what? Because if I type not in mine, I don't know. So I'm not sure, because I know that the Slurm commands are not by default colorized, because I had to develop some colorization. So I'm not sure. Maybe you can type. Yeah, the best.
But it's not now.
Yeah, we can have a look afterwards if you want, but I think it's not part of Slurm, because Slurm is always black and white. So I think I was here. You can attach some comments to your job. You can be notified by email when your job starts, ends, or fails. Make sure to provide the correct email. So Slurm does not know about your email, so you need to specify your email. And when you have a typo in the email, we get the email. So if you submit 1,000 jobs with a typo, we get 1,000 emails. And most of the time, we are not happy about that. So please try to make sure, do not copy paste this, basically, the number of, we sometimes get the email system saying, okay, you try to send an email to my@mail.com, doesn't work, I know. So you need to make sure to put the correct email here. And I said earlier, you can choose the name of the file that is created by Slurm. Okay, so in the example before, I wrote -- output equals result.txt, something like that. If you do that, you realize that if you submit 2 jobs, the second one will erase the output of the first one. So Slurm, by default, creates a file name with a placeholder here, which is the job ID. So when you define the name of the output file, if you put %J, Slurm will insert here the job ID. And that is what you saw in my working directory with all the Slurm dash and then some job ID. You can use the --test only parameter to only test a job. So if you have a typical job and you want to make sure that the submission script is okay, or try to know it if you will have to wait for 2 weeks before it starts, or if it's able to start earlier, you can use -- test only. So typically you have a submission script and you type sbatch -- test only, and then the name of your submission script, and Slurm will do everything as if it were a real job, except it will not submit it, but it will get a job ID, and it will make sure the job script is correct. And it will also give you an estimation of when the job would start if it were submitted for real. Also, but I will talk a bit about that later on, you can specify ordering between your jobs. So if you have 2 jobs and you want that one runs after another and not before, because maybe the output of one is the input of the other, you can use -- dependency, and you will see that there are multiple options here. So basically you can decide the order in which your jobs will run. Okay, so I suggest that you move your fingers a bit and try to run the sinfo command on the cluster that you are connected to, and try to see what are the limits, maximum running time. And if you use -NL sinfo, you will see a complete list of all the compute nodes. While if you run -R, you would see only the nodes that are down for a reason. So sometimes a cluster has 100 nodes, but maybe 2 or 3 are drained, as we call it in the Slurm language, meaning they are removed from the set of resources that are available, because maybe hardware must be replaced or they must be rebooted or something like that. So sinfo -R shows you what is going on. So here on Dragon 2, I can see that there are no nodes that are down. I can try to connect to another cluster where I know. So here you see on our manback cluster, sinfo -R, you see the reason, and then you see a listed node. Actually, there are many nodes that we are moving out of the cluster because they are old, they consume a lot of energy, and they are very slow. So we decommission them. You see some of them have a hardware issue. So sometimes you can think that, okay, there are 100 nodes in the cluster and there are 80 jobs. Why is my job not running? Maybe not all the nodes in the cluster are working. Sinfo -R shows you the reason why. Some of the CÉCI clusters can talk to each other easily. So actually, if you are on the method 3, you can see also the SQ from Dragon 2, or from Hercules. So here again, let me go to Dragon 2, and I can try to get so here you see actually the output of the queue on the method 3, because they are part of the same federation. So it's not working for all the clusters, but you can actually get information or even submit from one cluster to another. And this is with the -- clusters option, which is available for SQ, sinfo, and so on. As I said earlier, if you want to know if the sinfo command you are using is the basic one, or if it was tailored by your system administrator, you can type and then sinfo. If it shows you some code, or if it's an alias, it will tell you. And if you are with the output of a modified sinfo command, but you want the stock sinfo command, you can use command sinfo. So this is a bash command that instructs bash to ignore any alias or any function that would be called this way, and just run the executable. I've talked quite a few times about the maximum running time limits. I mean, there are actually other limits that you will find on the cluster, and you will find those limits with the asactemgr command. So S, because it's a Slurm command, ACCT stands for accounting, and MGR stands for manager. I will show examples, but basically with that command, you can see the limits, and the limits can be set either globally for all users. So typically this is the case for the maximum run. So for I don't have any examples right now. For instance, on NIC 5, there's a limit on the total number of CPU all users can use. So it's set globally for all users. Then you can have specific limits for specific user. So sometimes we have people who have jobs that put a lot of strain on the cluster, and we want the number of jobs running consequently, running at the same time to be capped at some value. And so we can do that for a specific user. There are limits that can be set at the quality of service level. So I said earlier, quality of service can be used to boost the priority, but limit the resources that you can request with that priority. It can be done at the accounting, what is okay. At the account level. So actually Slurm knows users, and users are grouped into accounts. On the CÉCI cluster, we only have one account, which is called CÉCI. But sometimes on clusters, you have multiple accounts. And so there are people working together in the same group, or people who fund things together. You can specify limits there, or you can have limits on partitions, like number of nodes in jobs and so on. And those limits can be the number of running or submitted jobs, the size of the job. Sometimes on smaller cluster, we don't want one job to use all the machines in the cluster. It can be on the duration of the job. I've talked about it. On the CPU usage of all jobs of a user. So sometimes we want to make sure that a user cannot submit 1,000 jobs running at the same time, or running one job with 1,000 CPU in it, if you want to make the job usage smaller. And we can limit the cluster usage of an account, but again, on the CÉCI, we only have one account. You can run I'm not sure you see it properly, but what this is a SACTMGR list user and then your username. So here I use the batch variable user. And then here with the format equal, I list all the columns that I want a SACTMGR to show. And these are all the limits that can be set on the cluster. And so what you see here, it's on NIC 5. There is a maximum of 510 jobs per user and a maximum of 648 CPUs per job for all users. So if you really want to know everything about limits, we have a page in the documentation that exactly explains how you can discover the limits and how you can try to make your way with them. One of the questions you will ask most of the time is, why is my job pending? And you can use the SQ command with --me and then -l, and you will see another column here, which is the reason. I said it earlier. I explained the reason for a job to be done here, for a node to be done. Sorry, here is a reason for a job to be waiting. I've talked about resources and priority. These are the most typical one, but there are other reasons for a job to be waiting. Sometimes it's partition node limit. So sometimes if you request more resources than the partition is able to offer, you will see that your job is held in this state. Dependency means that you have asked for this job to not start before another job. And so you will see the exact reasons here on this page. So this is from the main Slurm documentation. If you copy paste this in your browser, you will get a list of all possible pending codes with the reason written out beside it. So here, a little exercise I suggest that you try to run a job with a sleep 3000 command, but request only a 5 minutes runtime and see what is happening. So basically, you ask for some running time and then you try to use more than that, and you will see that Slurm will not let you do. Yes.
When you create the file to make the job to test run, that should be like the directory when you want to run the file. The test run and then you can like the directory.
srun expects the executable.
Yeah, but like for instance here there's like being my program my data one. So if I generate this text file somewhere else, like is that related to the directory or not?
I'll put the example back. Okay, so here, this is a full path to this program. So srun will run this program, and it will look for this program in this directory, but it will look for this data in the submission directory. So the directory where you type the sbatch command. Unless you use the --cwd option, which allows you to start to submit the job being in one directory, but you are asking Slurm to start a job in another directory. But most of the time you will be working in the same directory, but maybe you can insert here cd command, so change directory commands. So typically what can happen is that you have your job description files or job configuration file in a directory in your home, but your data are in the scratch, global scratch. So typically what you do is you run sbatch in your home directory, but here we insert cd global scratch something to change the directory where your data is. And then you run this, but then you need to make sure that either my prog is in the path variable, or you can write the full path to your executable. Okay, so Slurm has the notion of current working directory, just like Bash has that notion. And the working directory for job is the working directory at the moment where you type the sbatch command. So has anyone had their job killed by Slurm? Not yet. So basically you will see that Slurm will stop your job, will terminate your job after the time that you have requested during the submission. And actually it will do the same with the memory. If you request to have 10 gigabytes of memory for your job, but you try to allocate more memory in your program, Slurm will stop your job. If you want to try to use more CPUs that you have requested, Slurm will not kill your job, but it will constrain you to the set of CPUs that were allocated to you. So if you request one CPU, but you create 10 processes, you will see that all 10 processes will fight for the same CPU. Yes. Sorry, I didn't catch. It depends on the clusters. It depends in the, so you cannot use more CPUs in a job on a node than there are on the node. That there is that limit. But otherwise, the size of the job in terms of CPUs is limited depending on the clusters.
Jobs by several
It depends. It depends on the configuration of the cluster. So there's no direct limit expressed like that, but there can be a limit on the side on the number of CPUs per job and on the number of jobs per user. So with those two limits, you get effectively a limit on the number of CPUs per user. Any other question? Yes.
What is the export command? As export. I mean, because if I want, for example, to create a new directory in which I export my input file and I do all the jobs, all the other part in another directory, that then I cancel it and I remove once everything is done. How can I do export this export file? I mean, I send a Slurm, but I want to export the effective input file for, I don't know, Quantum Espresso. How can I do it?
So export is for environment variables. So
okay.
I'm not sure we are talking about the same thing. If you saw export,
okay. Because I have a script in which there is, so I wanted to know if this works also with the Slurm.
So export is a bash command
okay.
to specify the scope of a variable.
Okay.
So if you have files that you need to move around or to prepare, you need to use CP or rsync or things like that. But there are sessions later on about how to use the different file system with your jobs. So a main question that you more partition. So the question here was, what is the unit for the memory requirement? And the unit is megabyte if you do not specify it, but you can also write --mem per CPU, --mem equals 2, then capital J, it means 2 gigabytes. Yes?
The time format, is it hours and seconds? You use 2 columns?
If you, yes.
Okay, because actually I submitted the time less than the sleep, and yet actually continue to finish the job. So I didn't respond to the time.
On which cluster?
Okay.
You know the. So what you should do in that case, because this cannot happen. So what you need to do is to use scontrol and then show job and then the job ID, and you will see exactly. Yes, you can see it up like this, and then the job ID, and you will see exactly the time that Slurm has understood. So there are two options: either the time format was not correct, or you have, as I said before, a command before it that makes it. What is job ID? Maybe I can have a look afterwards, but Slurm does not allow you to last longer. But if you specify the --time, it doesn't matter which partition. You just have to make sure that what you specify is smaller than the maximum time for the partition. But the behavior will be the same if --time is below the minimum of the running times. Yes.
My job is I specified the debug partition, but it's running on batch.
So most probably you have a either a typo in the submission script or you have comments before the SBatch parameters.
Yes, and I do have the second option, the comments before, but then I tried specifying the partition in the call to the script, and it ended up being the same. So maybe it's that problem. I shouldn't put partition below other comments. That's right.
So if the partition in the script is below other comments, it will be ignored. If you have it on the command line, it should be in the correct partition.
Yeah, it will influence on batch.
Are you sure it's the same job ID?
I only have one. I killed the last one in order to be sure that I only have one job. And yes,
We can have a look, but that's not how it works.
So what I did was this.
Okay, so here, what you are doing is running the submission script.
Oh yeah, I should use SBatch. That's
Yeah.
right. Yes.
So-
Okay. Yeah.
And maybe that's what you did also. If you have a submission script and you run it, it does not go through Slurm. So anything that is about partition or memory or limits is ignored, and it runs on the front end. So make sure that you use the SBatch command and then the name of the script. So in the case here, the script was executed on the front end. And so normally it should even not appear in the SQ. But that's the issue. Yes.
I did a batch for script and I did 5 minutes. I still
No, this is fine.
oh,
Yeah. So the timing, the scale of the timings is not the millisecond or the second. So if you ask for 5 minutes, it could run for 6 minutes, depending on the busyness of the scheduler. But basically, if you ask for 1 day, you will not have 2 days. You can try.
Because actually I've tried this idea of like using this SQL control job, and it says that the time limit was 1 minute after I got now, and basically if I use the process SQL, it says that it passes that 1 minute.
Okay.
So it passes.
Yeah, but not twice the time limit. You cancel it by yourself. You canceled your job by yourself, or cancel cancel.
Oh yeah.
Maybe you can try after the session to do that again. But I'm positive that if you ask for a time limit, you will not go further than the time limit. If it were the case, we would know, because users always try to find their ways. So now what I would like to do is explain a bit how you can choose the resources, for instance, the running time. Basically, it's quite easy. It's an optimization problem that can be expressed like this. But the more resources you request, the longer you will wait in the queue, but the faster your job can be. Good. So it's a question of trade-off. If you have the number of CPUs here and the time it takes for a task to run, the larger the number, the smaller the time for running. But the more CPUs you ask here, the longer you will wait in the queue. So you understand that the total time to solution is a sum of those two terms. So it's a matter of trying to find the good balance, if you can, between the resources that you request, and the more resources, the faster your job, and the time you will have to wait for those resources. Not all jobs behave like this. So some just are flat like this because they are not scalable, as we say. So there are some problems where you can throw more resources and it would not go faster. So in that case, it's easy to decide that you only need one CPU or one node. But sometimes you need to make a scaling study and try to understand the relationship for your problem between the number of CPUs that you add and the time it takes for the solution to appear. If you have really no idea, what you can do is to run a smaller version of your problem, so your program and maybe smaller data on your laptop and use the top command. So the top command, if you run it, you have columns like this, and the two columns of interest here are res, which is the resident set size. This is the actual amount of memory that the program is using in the laptop. And then the second one is percentage CPU, which is the percentage of the CPU that your program is using. So this can be higher than 100 if your program is using more CPUs than one. So typically here, if you see on your laptop that percentage CPU goes to 500, it's a good indicator that on your submission script, you should request 5 CPUs, so that when it runs on a cluster, Slurm allocates 5 CPUs for your job. If you see here 100, there's no reason to try to offer more CPUs to the job, because most probably it will be stuck at using only one. So parallelization is not magical most of the time. If it's not built in the program, or if you did not write it by yourself, it will not happen. Sometimes if your program uses libraries that are parallelized, even though you don't write parallelized code, you can benefit from parallelization, so from using more CPUs, but that you need to test and make sure it's working. And that is one way with the top command to observe the resource usage in real time as your program is running. Okay, you can run it on your laptop or on the front end, but not for a long time. Another tool that you can use is the time command. So maybe you know about the bash time command. If you run time and then the command, at the end you get an information of how long the command has been running. But there's also on all Linux system the user bin time command. So this is an executable. You need to write the full path to use it, otherwise you are using the bash command. And if you use the -v here, you get information not only on the running time, but which is here, but also on the maximum resident set size, so the memory that were used by the program, and also the user time here, the percentage of CPU that the job got. And again, here, according to the number here, you can decide on the number of CPUs that you will request in your submission script. So these are two ways to try to decide in advance how many CPUs, how much memory you will request in your job. What you can also do is use guesstimates for the first job. Like it runs on my laptop. My laptop has 16 gigabytes of memory. I can request 16 gigabytes of memory for the job, but then you can use the accounting to better choose the resources with either the sstat command. So sstat gives you information about a running job, information about the memory and the CPU usage, and sact gives you the same information but for a stop job. So when a job is completed, it goes into accounting, and you can query the accounting with the sact. So an example here, just like many Slurm commands, you can choose the columns that are shown to you when you run the command. So here I use the dash format parameter, and then I specify the list of the columns that I want to see. And this is the list that I suggest that you use. It allows you to compare here the requested memory. So one capital JC means 1 gigabyte per core. And here is the maximum memory used over all tasks over the course of the job. You see that the job ID here has multiple lines, so multiple entries, and all these are the job steps. So this job has 2 job steps created by the user. So these are the result of some srun commands. And this is the entry related to the job script itself. So the job script is also executing, is also using memory. So it's showing here. And this is internal usage for Slurm, basically to capture some external sessions. I will not explain further. But so you see that for the same job ID, you have multiple lines, and each line corresponds to a job step. So you can compare the memory requested with the memory used. You can compare the time limit that you requested with the actually elapsed time. So here you see that I requested 5 minutes and it ran for 3 minutes. And you can compare the number of CPUs that you requested with the CPU time and the total CPU. So basically the CPU time is this column times this column, and the total CPU is the total CPU usage that your job has consumed. So this should be close to this. If here the number is half of this, you can say that you need only 1 CPU and the other one has been using those. You understand? So if you compare those two, they should be equivalent. If they are not, you can divide this number by the proportion here. So this is a way to see how tight the resource requests were when you submitted your job. So you can try to run the exact command to see your job history. So by default, if you run exact, you will see your jobs. Oops. Okay, I didn't do anything here. By default, it will show you for the day. With -A, it shows you all the clusters, all the jobs, sorry. And if you want to see the history, you can use --begin, I believe, and then a date. But I never yeah, I did. So with --start, you can specify that in the past from the point in the past where you want to see the jobs that have been running on the cluster for your user. Okay, so you can try to run it on your laptop, use stop or time to see the resource consumed. You can run it on the cluster and then use the accounting asset to see the actual resource usage. And you can also use profiling tools, which is of course the best approach, which are tools that will run the software and at the same time measure everything about the program and give you information about the memory usage over time and the CPU usage over time. And there's a specific session about profiling tools later on in the session, so feel free to attend it to learn a bit more about it. Any more questions? Maybe we can have a small break or a question before, yes?
When a program fails, so it is like before the failure, it gets rescued. And so the way to govern, so basically what I do is say with the small pattern that the full start, then sleep for 5 minutes, allow it already to the time of 2 minutes, and full start.
So there are multiple things that can happen actually when you write something to the standard output. There are buffers. So there are buffers at the Python level, at the Slurm level, at the file system level. So it could be that your job was abruptly killed before one of those buffers was flushed to the disk. But I'm surprised. You should, or if your Python script did not close the file, that could happen. So if you have an open, a print, sleep, and then it's killed, it could be still in the buffer. But if you have open, print, close, sleep, you should see the line. But there are multiple buffers that are managed by different parts of the cluster, and they are difficult to debug. So I suggest we have a 10-minute break so that I can renew the air here. Yes. No. That means it has run offset already. Yes, if you run a stack, that's easy. So the command that was there, SACCT. So accounting. So yes. See the last one. So if it no, because this is an error that happens before the job is even submitted. Okay. So what you need to do is look into the output file. So if you get the file in the directory with ls, or yes, you see that there's the res.txt, and so you can look in there with cat c8 space. Yes. So it complains that there's no such file in my data. So either you copy it exactly, but then he says the script was an old file, which is a file that does not exist, and so it fails because of that.
But then, like, so.
But everything worked as expected.
Yes, first I tried to.
Yes, that should have worked.
Yeah, but it did the same, it didn't show because it wasn't great.
Yes, okay. Yeah, okay. But then if you specify the same output file,
yeah,
it overwrote
yeah,
the previous one.
No, I'm putting it.
Okay.
But then when I'm not really sure about it, like what I'm running.
So hostname is a command, is a program that is installed on every Linux machine that just displays the name of the machine.
So for instance, like for me, it's important that one to one my code of my account, so I'm not sure why.
So if it's your code, you will decide how do you
Run the
name
function or the script,
the script. Yes. Non, mais ça c'est pas vite, c'est le batch. Et lui, c'est un peu normal, parce qu'en fait, il démarre, il lance vite, il attend juste que et donc lui, c'est normal qu'il fasse rien. Mais parfois, il y a des scripts qui font des choses, qui calculent des IO à côté. Lui, c'est normal qu'il fasse rien. En fait, external, c'est un faux step que Slurm met pour des raisons internes pour pouvoir capturer. En fait, quand tu soumets un job, c'est sur le même code. Sur le métro 3, tu ne peux pas te connecter sur une machine directement au SSH, sauf si tu as un job qui tourne. Et quand tu fais ça, et que tu te connectes alors que tu as un job qui tourne, ce que tu fais dans ta connexion SSH est géré dans ce step-là. Ouais, mais en fait, il y a une pratique S7-X. Mais juste les job ID, alors tu n'as pas la commission. Mais pour le temps, tu l'as. Ah non, tu l'as pas. Non, tu peux juste regarder. Non, non, parce que ouais. Alors, on peut directement lancer dans un script, mais je ne fais jamais, je ne le fais pas. Parce que après, si tu prends le script, tu le sur ton laptop, tu peux se passer des choses. Donc, le mieux, c'est de faire un script de solution. Donc, style comme ça, exactement. Ce que ici, plutôt que de ça, tu mets R-script, la syntaxe R, le fichier de syntaxe R. Alors, tu fais les deux vont fonctionner. Si tu mets Scrum dans la conduite, tu auras une ligne spécifique là. Si tu ne veux pas, tu auras juste des informations globales. Mais si tu as un step, ben, ça fait la même chose. Et par contre, si tu utilises slow, ou aussi, ou des trucs qui permettent de travailler en parallèle, est-ce que peut avoir un impact sur la manière dont ça se passe? En parallèle, alors, si ça reste sur plusieurs cœurs de la machine, si par exemple, ça peut ne pas être lancé par la semaine. Par contre, si c'est avec LMPI sur plusieurs machines, oui, c'est ça. C'est la en fait, le truc, c'est que c'est quelque chose ou un comportement différent en fonction des mécanismes de chaque. Par exemple, si tu fais un jeu parallèle en chargeant le store, d'un coup, il fait plein de trucs en plus, tu peux s'agir. Mais si tu le fais avec lui, ça fait que sur le site. Donc là, ça laisse un problème de. C'est des donc, c'est un CPU pendant 2 heures, c'est 2 CPU, 2 CPU pendant 1 heure, c'est 2 heures. Donc ici, tu as 150 CPU. Alors, c'est pas dans le fond, ça, c'est vraiment du temps de consommation de CPU. Mais si tu as plusieurs CPU, c'est quand tu travailles en parallèle, c'est un peu que si tu veux encore le temps, le produit du niveau de CPU, le temps qu'ils ont tourné, et ça coûte comme des kilowattheures. 5 km par heure, c'est ça. C'est ça. Donc, le temps, ça c'est vraiment un temps linéaire, et ça vient du CPU. Quand tu multiplies les deux, ton unité, c'est une unité de temps fois une unité de CPU. c'est l'intégral de l'utilisation. Et en fait, tu compares ça, qui est le rectangle, du produit, avec l'intégrale de l'utilisation de et tu veux que l'utilisation remplisse le carré, enfin, tu remplisse le carré au maximum. Et sinon, remplit la moitié du carré, et le carré par balle. So one interesting question here was in the time format, if you see a dash and a number before that, it's a number of days. So 2 dash something is 2 days and then hours, minutes, and seconds. But you can specify 48 hours. Slurm will understand that it's 2 days. Yeah, I think I'll start back again in 3 minutes. I don't remember when I stopped. Because we still have this week. So the CPU time is actually exactly what I was. So the CPU time is the particular CPU time. So if you have one CPU used for 1 hour, it's 1 CPU hour. If you have 2 CPUs used for 1 hour, it's 2 CPU hours. So what you need to make sure what should be the output side is that this number is divided by plus this number. No, because CPU can be in terms of CPU, you cannot actually Slurm will not tell you this for CPU, but it just constrain the process on a set of CPU, and actually if the single process is compared to the CPU, or if the processes are not able to use CPU, you will just see that the usage is smaller than the so in this process you will see that the CPU usage per process is more than and your program is not able to use when you can use CPU usage. Hello. So here, if you divide this by if you divide the total CPU by the web CPU, you should have a number which is the same as the CPU. If you close the number, you can remove you can remove the number. So you need to know the CPU settings. CPU time and you divide by the time, you need to figure out that one CPU that will use. Okay, welcome back. Do you want me to leave the windows open or do I close them? Do we have too much wind or? Oh. Okay, so what we'll be discussing now is priorities. And now we try to be a bit quick on this because I have a lot of material to go through. But basically, the priority that Slurm attaches to a job is a function of multiple factors, multiple terms. You see here an age, a fair share, a job size, a partition, and QoS. So the priority depends on many things. It depends on how the cluster was configured. If you want to know exactly how it works, you can have a look in the Slurm documentation. It's a specific plugin that takes care of computing the priority, and that plugin is called multifactor. To get the priority for your job, you can use the sprior command. So prior as priority, and S because it's a Slurm command. And with sprior, you will see the individual terms in the sum that are responsible for the computation of the priority of your job. SQ will give you the priority of the job, and sprior will give you the details. So you can have a look on a cluster. If you run sprior as is, you will see the priorities of all the jobs, and you will see how the priority is computed for all jobs. And if you use -w, you will see actually the weights associated to each term in the computation of the priority. And you will see that on some cluster, the job size has a large weight, on some other, the fair share has a large weight, and so on. The fair share is one of the most important factor. It's the one that makes sure that everyone has a fair access to the cluster. So how does it work? The share of the cluster is like a big pie. We slice the pie and we hand out shares. So you have basically a fair share of 1 divided by the number of CÉCI users, so that everyone has the same share of the cluster. But not all of you use the same amount of resources all the time. So what happens is that if you are using a lot of resources, your fair share is decreased. And if you don't use the resources, your fair share is increased. So that the priority reflects in a way how much of the cluster you've been using in the past. So if you have never been using the cluster, you have the highest priority possible. So based on the fair share, but it's not the only factor, as you remember, but as long as your fair share is concerned, it's maximum. But if you just finish the 1000 CPU job, your fair share will be very small. And then as time evolves, your fair share will regrow. So the actual formula is like this. So here I was a bit lazy. I took the slides from the company that writes Slurm directly, because it's a way for me to not having to explain it too much. But basically you see that it's a 2 exponent and negative component, which is based on the effective usage and the share. So the share that we discussed, which is 1 over the number of users, and the actual usage, they are compared, they are put into this formula, and this formula is used to create a number between 0 and 1, which is used as a factor for the priority computation. Here you see effective usage, and you see it's decayed somewhere. It's what I explained. So the actual usage that Slurm takes into account decays over time. So if you used half of the cluster in the last day, is not the same as if you used half of the cluster 2 months ago. So there's a decay factor in the importance of the past usage for the computation of the actual priority. You can get your current share with S share. Again, the name starts with an S and ends with what it does. So it's a tool for listing the shares of associations to a cluster. So the term association in Slurm means quadruplet of user, partition, account, and QoS. So Slurm takes accounting based on those four things. If you have a user and you have access to multiple partitions and maybe multiple QoSs, each combination is an association. So you can have a look at the current share of users. You can actually see the share of everyone. And here I show you how to compute one column from another. It's not very interesting, but if you are convinced that Slurm is lying to you, you can try to go back to this slide and try to reconcile the columns. One important thing is that priority is not actually the only thing that decides when your job starts. The other thing is called backfill. You remember this picture from a few slides ago? So you see here the resources, the time, and the job is usage of resources over time. And here you see three jobs, one with priority 100, priority 70, priority 80, and let's just assume that we have two more jobs that appear, one with priority 90 and one with priority 10. And you see that this one has a higher priority than this one. But this one is smaller and this one is larger. So actually what Slurm will do, it will consider this job and say, okay, this one is higher priority, it will be next to run. But because it requires a large amount of resources, it cannot start before this job is finished, okay? Because it needs the resources that will be freed by this job when it finishes to start. So that means that here, visually, you can see a hole and you can see that visually, this one fits. And so Slurm puts that here. Okay, so very natural. The idea being that Slurm will never delay the start time of a higher priority job because of a smaller priority job. But if this job is able to start and finish without delaying the other jobs, it will do so. Okay, very interesting, because it means that if you have a job and you give it the default time value, it will never be backfilled. Okay, so if you know your job will only run for 1 hour, but you request 5 days, you penalize yourself because it will never be in this situation. And again, if you request the default amount of memory per core, but you don't need it, you see that actually you can be blocked and not fit, not horizontally, but vertically in this graph. So the tighter the resources, the higher the probability that your jobs will be backfilled. And the order in which jobs are considered for backfilling is based on the priority. So if I had two jobs with the same size here, it would be the job with the highest probability, highest priority that is started. Okay, so backfill is a very important concept, both for us to make sure that the cluster is fully utilized at most time, but also for you, if you have a job and you see a very large queue, a large number of jobs that are running, a large number of jobs that are waiting, and you want to make a small test, you should submit your job with a small running time, and the chances are great or large that your job will start before all the others, just filling a small hole in the scheduling plan. Okay, so don't be disheartened if you see a large number of jobs. If you have a small job, you can hope on backfill for your job to start. Any question about this? No. So now, most of the time I've been talking about one CPU in the examples I've shown, but the power of the cluster lies in the number of CPUs. So you have 100 nodes, and each node has multiple CPUs, and each CPU has multiple cores. And actually, you can ask Slurm multiple cores for your job. The way you do that must be based on the way your program is written. So here I will show you examples of multi-node submission script, single node submission script, and so on. The most of the time, if you hear me talking about MPI or OpenMP, these are libraries or techniques that are used to create parallel programs. There are sessions dedicated to it that are planned after. This is the first year that this session is planned before. So in my mind, you have all followed those sessions, but it's not the case. So if I'm talking about MPI and making assumptions that you are wrong, do not hesitate to interrupt me and ask a clarification. I will try to explain what you need to know about MPI to be able to understand what I say without ruining all the MPI session afterwards. Okay, but MPI is basically a library to write parallel software that work on multi-node clusters. Some other techniques allow you to write parallel programs that only can work on a single node. So a program that can use multiple cores inside the same node, but not multiple cores from multiple nodes. You can have master-slave programs. So basically, MPI and OpenMP are both SPMD, meaning that there's only one program that is duplicated to run the parallel stuff. But sometimes you have either leader, follower, master-slave. It depends on how you want to write it. Programs where you have one program that does the organization of the work and others that do the actual work. We will see embarrassingly parallel workloads, which is a way to describe problems where you can split the problems into independent parts, and each independent part can be solved by an independent job. And then we will see how to submit jobs so that Slurm gives you a GPU. So in Slurm, the important context is the number of tasks. And the number of tasks must be think of in the context of a multi-node problem most of the time. So this is for an MPI program. If you have a program and you know that it was written and compiled with the MPI support, then you know that you need to specify a number of processes to your MPI program. And in Slurm, this will be called a task. And so if you have if you want to launch n MPI processes on n CPUs on the cluster, you just specify --n tasks equal n. If you know about MPI, you know that you typically run an MPI program with MPI run. And then normally, if you are not in Slurm, you specify the number of processes that you want to create. But here, inside the context of Slurm, MPI run will ask Slurm how many CPUs were allocated to the job, so you don't need to write it again. So here I write sbatch n task equal 4, and this will make MPI run or srun start this program with 4 processes running on possibly 4 distinct nodes, or maybe on all the same nodes, depending on how Slurm was able to pack together the resources that are requested. The difference between starting with MPI run or with srun is mostly technical. So this srun will is a Slurm utility. This MPI run is an open MPI utility or MPH utility. But both are actually using information provided by the other. So depending on what you want to do, there are specific options that are available only with srun or only with MPI run. So most of the time, if you see my colleague who gives the open MPI session, he will tell you that you need to start with MPI run. And if you ask me, because I give the Slurm session, I will tell you that you need to start with srun. Most of the time, you can do whichever is best for you. So here, with just n tasks, you don't specify anything about the distribution of the CPUs or on the nodes. You just ask them, okay, the soonest possible is give me 4 CPUs on the cluster. But you can specify that you want CPUs to be spread across multiple nodes. And how you can do that is specify n tasks equal and then n nodes equal. So if you specify the same number here and here, you will end up with an allocation where you have 1 CPU on 1 node. So you have 1 CPU per node on the number of nodes that you specified both here or here. It's the same that if you specify n tasks equal n and then and task per node equal 1. So the names are pretty self-explanatory, and there are multiple ways to specify the allocation that you want. You can so spread across distinct nodes, or try to put all on the same node. And so if you understand how this works, you understand that if you put n tasks and n tasks per node, or if you specify n nodes equals 1, Slurm will only start your job if he can find one node where all the slots can be found. And you can find in between situations if you want only 2 tasks per node or so. The -- exclusive option is used to make sure that the jobs are on nodes which are not shared. So by default, Slurm will share the nodes. If you have 2 jobs asking for 1 CPU and there are nodes with 2 CPUs, both jobs will start on the same node. Sometimes for a lot of reasons, you might not want that. So in that case, you add -- exclusive to your submission script, and Slurm will only allocate the jobs to you, the nodes to your jobs. So it's a way to make sure that there's nobody around when you run on a node, but it also will most of the time block more resources that you actually need. Because if you only need 1 GB of memory and 2 CPUs, and you use -- exclusive on a machine that has half a terabyte of RAM and 100 CPUs, actually you are blocking all the other resources for the other jobs. Yes? Yes. So here I'm ignoring that option, so it means that it's 1. But that option is for shared memory jobs, where you specify n CPUs per task. Okay, so at the end, you will understand how it all fits. But here I was talking about task, and a task is a process or a unit of program that can be placed on any node. And that unit of programming can use multiple CPUs. And you can specify that with n CPUs per task. This is typically used with OpenMP or pthreads, if that talks to you. So programs that can use multiple cores on the same machine, not on multiple machines, but on the same machine. And here you see that I'm requesting 4 CPUs per task. And this will have the effect that all the CPUs that Slurm will give me will be on the same node. That's the main difference between tasks. If you ask for 4 tasks and 1 CPU per task implicitly, then you can get 4 CPUs on 4 nodes, or you can get 4 CPUs on 1 node, or 1 CPU on 4 nodes, or 2 CPU on 1 node and 1 CPU on 2 nodes, or any combination. Here, because it's meant for programs that are not able to run on multiple nodes, you will get all the allocation on the same node. Here again, you can use -- exclusive to request a full node. So sometimes you have a OpenMP program, and you know that it scales well, meaning that you don't need to you don't care basically about how many CPUs it uses, and you want the job to use all the CPUs of a node. Then you can use -- exclusive and -- memory equals 0, which actually means not 0, but all the memory of the node. And this is a way to ask Slurm to get a full node and not care about the number of CPUs that are on the node. When you are on a homogeneous cluster where all the compute nodes are identical, this does not make too much sense. But sometimes you have multiple versions or multiple generations of computers, and the number of CPUs per node is not always the same. And if you specify 24 CPUs and there are nodes with 24 CPUs and nodes with 28 CPUs, if you end up on a node with 28 CPUs, then you end up not using 4 CPUs that you could have been using. So if you specify -- exclusive, whatever the number of CPUs offered by the node, you get the whole node, and your program knows about all the CPUs that were allocated in the node. Okay, so we've seen multi-node MPI, single node OpenMP. Yes.
That's good. Do them using like workloads using sign workload?
So an MPI program which can be multi-node can of course all run in a single node. There are advantages and disadvantages. So the advantages is that the memory channel, the memory is not shared. So actually the memory writes and read can be more parallelized than if sorry, I'm comparing two different things. So if you if you have an MPI program on a single node, I will be short. Sometimes it can be beneficial for the IOs. Sometimes it can be adversarial for the IOs. Depends on the way memory read, writes, network read, writes, and computations are overlapping. Sometimes you want to be all on the same node so that you don't lose the network too much, but you put a higher strain on the memory. But sometimes you want to spread across the network. If you want to put a higher strain on the disk, for instance, if you do a lot of I/O to a disk, you would want to write from multiple nodes rather than all the processes from the same node on the same disk, if you see what I mean. So there are cases, it depends on the program, where you want to be as spread as possible, or you want to be as compact as possible. It depends on how access to memory, disk, and network, and CPU are organized in the computations. Another type of program is when you have multiple types of, so master slave or worker slaves, coordinator worker here, as I wrote here. This is done with the -- multiprog option of SRun. So if your problem is solved by a program that calls other programs, you need to write a configuration file like this, which defines which program must be run by which task number. So if you request n tasks equal 4, Slurm will give a number to each task from 0 to 3. And then you can specify that task 0, so which will be allocated a CPU, will run this program, while the other task will run this program. So this is a way to run a master-slave setup. So this is often seen in programs that come from the MATLAB world, basically. Another aspect of a Slurm job is the array. So here I've described one job, but most of the time you will have multiple jobs to submit. And if you have a large number of jobs that are mostly identical except for some parameter, which you could call the parameters job, you can submit an array. So if you have a SPH -- array here equals 1 to 4, it actually asks Slurm to not only create one job, but 4 jobs, all identical, except for this environment variable that will be set by Slurm from 1 to 4 in each of the 4 jobs. Okay, so if I have this submission script, Slurm will actually create 4 jobs, and each of the 4 jobs will see, in a sense, a different value for this variable. So it allows you to change the behavior of the job inside the script, taking into account this variable. So here what you see the example. Actually, this example, you can run it on any CÉCI cluster, it will work. So what you see is that first I'm testing if some program is already there, because it's a program that I want to run. But given that I'm creating an array, all the jobs in the array are independent, so they might be running at the same time or not. But if I'm copying a file, I don't want all of them to copy the file, because the first one that will copy the file will do it for all the others. So here I'm just testing if a file exists. If not, it copies the file from the CÉCI storage, and then it runs the file with an argument in the command line, which is here the number of the task rank in the array. So we have 4 jobs. The first one will run array hello 1, the second one will run array hello 2, and so on. And in the end, you will have 4 output files with the 4 output of the 4 jobs that are all identical except for the value of this environment variable. Yes.
So for instance, if you want to use this context analysis, let's say like each of the words are given user input, how do you save them so that it will go to the one to three like this 4?
We'll see many examples afterwards. Because here, what a drawback that you can already see is that this is an integer, a positive and non-negative integer. And sometimes the analysis, you want floating points values, or you have multiple files or so on. And so we need to add a bit of bash recipes here, but it's a subject of another section. If you need GPUs, and if you know what GPUs are, and you know your program is capable of using GPUs, you can request them with --GPUs or --GRS. I won't talk more about that, except if you have questions. The difference between both is that if you request GPUs, you give here a total number of GPUs for the job. But if you request GRS equal GPU, you're actually requesting that amount of GPUs per node in the job. So here again, if you copy paste this on a cluster that has GPUs and you submit it to a partition that has nodes with GPUs, it will show you the output of NVIDIA SMI. And the same with GPUs as other resources. If the cluster is correctly configured, if you don't request the GPU here and you run this command, the NVIDIA SMI will say, okay, I can't find any GPU, because Slurm will hide them from you. So we've seen multiple types of jobs, and actually you can mix them in a way. So if you have a hybrid job, MPI and OpenMP, so MPI is specifying a number of processes, so tasks in some lingo, and OpenMP is specifying a number of CPUs. You can have both, and in the end, you get this times this amount of CPUs allocated to your job. But because you ask it like this, you know that the distribution of CPUs will already be by 4. So you can end up with 8 times 4 CPUs on 8 different nodes, or you can end up with any combination that gives you that amount, so 32 CPUs, provided that any group of 4 is always on a single node, on the same node. So you cannot have, with this specification, 30 CPUs on one node and 2 CPUs on another node. But you could have 28 and 4, or you could have 16, 16, any combination that works. And you can use all the other options that we have seen earlier to decide exactly that you want maybe 2 tasks with each 4 CPUs on each node, not more, not less. But the stricter you are in your resource request, the longer it might take for Slurm to find the resources. And you can create an array of hybrid jobs just by adding as batch array here. Okay, any questions about this? So it's a bit abstract, but the more lessons or training sessions you attend, the clearer it will become in the future. Yes? So if your program is OpenMP or if your program is shared memory, it's 1 and 32. If your program is MPI or distributed memory, it's 32 and nodes equals 1. It really depends on how the software is written. In the end, it's always 32 CPUs on the same node. But for Slurm, there are subtleties in how the information is conveyed from Slurm to the program.
The number of nodes, option will be
most of the time it's used on clusters where, very large clusters, where you specify a number of nodes and you don't ask for single tasks. on the Lumi or large cluster like that, the basic unit of allocation is not the CPU, it's the whole node. And so in that case, you request a number of nodes. Yes. And if you request 10 nodes, you get 10 full nodes with 10 tasks. And then it's the job of your program to distribute a tenth of the task, of the total task on the nodes. But here at the CÉCI, we have only a small cluster with a maximum of 100 nodes. And so the basic unit of allocation is a CPU core. So here in this section, I will explain a bit some basic workflows. So because until now, we've been talking about submitting one job, but you will see that throughout your queries, you will most probably submit a large number of jobs. The idea is how can you work to be efficient in that job submission process? The first thing I would like you to learn is how to script submissions. So sometimes you write a submission script, you run as batch, and then a second one, and you run as batch, and then the second one, and you are wondering, can I automate this? And the answer is yes, provided that you use the --w wrap option of as batch. So here is an example of a submission script. This is equivalent to this if you don't want to use a submission script. Okay, so what you see here, I'm requesting 4 CPUs per task. I'm exporting a environment variable, and I'm using some program. And I can do exactly the same here. You see that this part is here. This part, which is modifying the environment, is here. So as batch, it's important to note that as batch will convey the whole environment in which it was when it was invoked to the compute node, to the job. So if you define an environment variable here and you export it, as batch will define the same environment variable on the compute node for your program to start. And then you see that the actual computation here is just written here as an argument --wrap. Okay, so if you are in a process where you don't want or don't need to create a submission script, you can submit on the fly with the --wrap. Okay, you see the idea? And the main thing is that, of course, this being only a single command line, you can script it in multiple ways. And I would like to show you some tools that are useful for that, namely Xargs. So Xargs is a tool from the Linux world, which is available on every Linux machine, that allows you to take in standard input a list and then run multiple times the same program with each element of the list. Okay, so here the example states that I have 3 files, data_red, data blue, and data green in some directory. If I do ls all of these, I will list all the 3 files, and then Xargs, what it will do, it will take this part, replace the placeholder here, the curly braces, with each of the elements here. And so this will be equivalent to running by hand all of these 3 lines. Okay, so this is a way to automate submission of multiple jobs that each must take care of one single file, for instance. Here is another example where we could see here, this as a parametric study, where you have a parameter that needs to go from 0 to 1 with a step of 0.1. Again, here, sec will create the whole sequence, and then Xargs will take each element of the sequence and and put it here at the place of the placeholder. So this whole line will be equivalent to 10 lines here, all the same, except for this part here that will be replaced with each element of this sequence. Yes?
Sorry, I don't understand. What is the function of wrap, of the wrap?
It's to avoid having to create a submission script.
Ah, okay.
So what you would put in the submission script, you put in the quotes here afterwards.
Ah, okay. Okay.
In some later session on parallel computing, I will talk about GNU parallel. Just showing you that it's an easy way as well to create multiple jobs. So with this single line, which I will not explain, if you want to understand, come to my session about parallel computing. This is equivalent to all these lines. So you see that the first placeholder here is replaced by a number from 1 to 3, and the second one by a letter from A to C with all possible combination. So it's an easy way in one command. Yeah, be careful. With one command, you can submit a huge amount of jobs, and I will have to clean up after you if you make a mistake. Yes.
Can I also put everything in a simple in a simple script, so that I don't have the single line? I mean, I can put it in a script. It's following the same procedure, but put it in a script.
But then you cannot use this type of placeholder in the script.
That was my question. I can't use
No.
it. Okay.
That's why we use the wrap option here, because where is it? Well, parallel will not be able to go inside the script changing things. We'll see if you slice something similar, but not quite.
I mean, I could use instead if I invoke a Python shell for loop. No. If I invoke a Python shell, the Python shell,
Yes.
couldn't I do the same work with a for loop?
Yes, you can. Okay. Here, the idea is not to write a loop; it's a single line, and I don't have to think about how the. But if you are more familiar with Python, you can use os.system and then sbatch and then something just to script the submissions. It will work. Yes.
Sometimes when you instruct to run a program, it begins with srun and sometimes just /. Is there a reason for that?
Yeah, so sometimes I use srun, sometimes I don't. Srun must be used when you have a multi-node program, so either MPI or multi-prog. If it's not a multi-node, you are not forced to use it. But if you don't use it, all the accounting is attributed to the submission script. If you use it, you have one line per invocation of srun. And the second thing is that if you use srun, you will get real-time information about the consumption of memory and CPU with stat. So I mentioned the stat before. I was not maybe clear about that. Stat will give you the information only if your program was started with srun. If you did not start it with srun, then you need to wait for the completion of the job to get the information after it. Okay, so here is an easy way to not having to write a script in any language to submit a large number of jobs, just with xargs or parallel. What I'm showing here is a bit the same idea, except that rather than scripting a submission, I will submit a job array. And I said earlier that the array, the index in the job array is an integer. This is a way to make so that the index in the array is a file. Okay, so I create a job array with 3 jobs, and I create a bash array with, assuming here, 3 files. And then I can use bash constructs like this. So I have files here, which is an array with 3 files. And I use the task ID as an index in that array, simply to get the ith file in the array. Okay, you have to make sure that this number is the same as the number that will be as the size of the array that will be created here. But other than that, it will work nicely. Okay, so if you have an array, if you want to do a Slurm job array, but you don't have an integer and you have multiple files, the trick is to go through a bash array. So don't mix up the Slurm array with the bash array. but basically you need to create a Slurm array, a bash array, and make sure that you use the same index symbol. The same holds if you want to use the sequence here, just like before. The idea is my parameter is not an integer, it's a floating point value from 0 to 1. Then you can do it like this, it will work exactly the same. So here the idea being that my prog expects one parameter that should go from 0 to 1 with a step of 0.1. And here the difference between scripting that is that we get an array. And the nice thing about arrays is first that the scheduler is it's easier for the scheduler to work when it has arrays rather than when you submit a large number of jobs. And also for you, you can cancel, for instance, or modify all jobs in an array with a single command. But you can also modify a single job in an array with a command. The idea is that all jobs have the same job ID with an underscore and then an index, which is the number of the job ID, the job in the array. Here is an example where I have a CSV file with 2 columns. First column is number, second one is a letter, and I'm assuming this is a description of all the jobs that I want to submit. Here again, with a construct like this, simply you can create a job array that will run my prog with each job will have will take care of a line in the file if you want. So the first one will be my prog 1A, the second one will be my prog 2A, and so on. So sometimes you don't want to have all combinations like Parallel can give you, but you have a file with all the information about the description of the jobs that you want to run. So here you can use some construct with, here I'm using the set command to extract the line in the file. So that recipe can be used for any file that you want, where you want to process one line in the file per job in the array. Okay, so this is more about bash than it is about Slurm actually, but it's constructs that are useful to know. So I'm going a bit quicker here, but do not hesitate to interrupt if you need. This is another example. Some programs do not expect arguments in the command line, but rather in the configuration file. And here, but I'm not going to go into detail, but the thing is that with the end sub command, which is a bash command, you can create templates. And then with bash arrays, you can create a job submission script that actually creates one file. So based on the template and based on environment variables. So there are programs that require the parameters to be stored in a file. With a construct like this, you can have a job array that will create all the different files that you need without you having to copy a file, modify a value, and copy again, modify another value, and then submit a job for each of them. I would like also to show you how to pack jobs. So here I was assuming that if you had multiple tasks, multiple things to do, you would do multiple jobs. But if the task that you have to perform is short in time, it doesn't make sense to submit 1,000 jobs running for 10 seconds each, because Slurm will have a lot of job to do just scheduling all those jobs. So if they all fit into one job, you can pack them. So here is an example where I'm requesting 8 tasks. So Slurm will give me 8 processors that it can find in the cluster, but I'm running srun 1,000 times. And I put all these sruns in the background, and then I use the wait command here. Otherwise, Slurm will not wait, and it will consider it's done, even if it's not. And each srun, I'm asking it to use a sub-allocation. So each srun will not use all 8 tasks or all ASAP, but only one. And so with a construct like this, what will happen is that bash will create 1,000 invocation of srun, but srun, they know that they can only run 8 by 8. So the first 8 instances will run, and the other will just sleep. And as soon as one of them has finished, another one that was sleeping will start. Okay, so it's a way to pack, to do micro scheduling. So inside an allocation, you run multiple things and you let Slurm do the work of making sure that actually you don't run all instances at the same time, because you will run into problems if you have many more processes than you have available CPUs. But with this, you can just do that. If you prefer, if you don't like to write for loops, you can use parallel here in the same way. So here, it's the other way around. A few slides earlier, we used parallel to submit a large number of jobs. Here, we use parallel inside the submission script to run multiple tasks inside the same job. This is basically doing exactly the same as the for loop as earlier, with one difference though, is that here, parallel would take care of not running more than 8 instances of srun at the same time. So it will be a bit more efficient, but only marginally. You can also use xargs exactly as before, rather than having here as batch, here I have as run, and rather than running this in the bash command line, I run this in the submission script. And so here I submit a job that will organize a large number of small tasks inside its own allocation. Any question about that? You get the idea? Maybe the details are a bit blurry, but it's all explained in the documentation, in our documentation. One thing that also is interesting, if you are in the scripting of submission, with the -- parsable option, Slurm will only output the job ID. If you remember when you used sbatch, in the past it said, okay, job submitted, something. But if you want to capture the job ID or something else, use -- parsable. And then the output will be more terse and it will be easier to parse. Here I still have this bizarre construct because when the cluster is part of a federation, it still gives the name of the cluster. So if you want to get rid of the name of the cluster, you can write it like this. And here what I'm doing, if you understand what is happening, is that I'm submitting a first job, capturing the job ID in a variable called ID. And then I have another for loop here that does also job submissions and capturing the ID, but it uses the -- dependency after OK and then the ID here. So basically what this does, if you give it 4 job submission script, it will submit the first one, and then as soon as it knows the job ID of the first one, it submits the second one with a dependency on the first one. So when you have multiple jobs that are, for instance, a pre-processing job, a processing job, a post-processing job, a cleanup job, you need them to run in sequence. This is a way to, if you create a small script like this, you can use it like this just to chain all these jobs. Any question about that? You get the idea? Another interesting constraint is this one. I've been talking a lot about the time limits on the clusters. Here is a way to work easily if you have a program that is able to checkpoint and restart, which is the topic of next session. So if you have a program that when you stop it, it restarts where it was stopped and does not start from the beginning. So you know it can be stopped abruptly and then you can resubmit the same job exactly. If you are in this situation, then you can do something like this. You request, for instance, 24 hours, which could be, for instance, the limit on the partition that you target. And then you use a timeout program, which is a bash program, and you give it a slightly lower value here, and you run your program through this program. What will happen is that timeout will stop your program after this amount of time, and it will have a return variable, which you can capture here like this, which will be this value exactly if it had to kill it. So basically what this happened is that if your program runs for 12 hours, nothing here happens. But if it runs for 23 hours, then this condition will be true, and this will be run. And so basically, S control requeue and then your job ID will re-put the job in the queue. So if you have a program that you know will run for 3 days, this will typically cut it in 3 parts. Well, actually in 4 parts, because the last part will be 3 hours. Okay, so it's an easy way to automatically resubmit a job as when it's not finished. But that can only work with programs that can be stopped and restarted without further intervention from the user. Yes? Sorry?
So the data is inside the program, something like that. But the can you still use the same data that you're using?
It depends on how the program is written. So that's why the program needs to be written in a way that it knows it can be stopped abruptly, and it knows that it has to have a way to restart properly. So if you do this with a program that was not written in this way, it will not work. You will just run the same first part of the processing all the time. But this is discussed in length in the session that is coming. And also here, what I show you are actually small workflow systems, workflows, but there are systems that can help you manage a large amount of jobs automatically for you. And this was a topic of a seminar series for which you can find the videos on our YouTube channel, which you can reach through this URL. And we also wrote some documentation on which tools can be useful in which type of workflows, because workflows are as diverse as there are people working in all the different domains. So I just encourage you to have a look at this page, and if you find that some workflow fits the way you are working, then you will find links to the videos that explain the tools a bit more. One more thing. We have a wizard to help you create a job script on the website. So you just fill in here the information, you choose the cluster for which you want to work, and then you have here a submission script which you can copy paste on the cluster. And based on what you choose here, the list here will evolve. So for instance, if you request GPUs here, only the clusters with GPUs here will be available. Okay, I'm sorry, I need to go faster now because my time is over. Do any of you use RStudio or Jupyter Lab, Jupyter Hub? Yes, okay. So here I will explain how to use such programs which have an interactive interface. When I said earlier that the batch system does not allow you to interact with the problem, basically what you will use is salloc to create an allocation, or srun. This is the other option. Typically, salloc will be used if you have a multi-node setup, which I believe with Jupyter Lab or Jupyter Hub will most often not be the case. So with srun, if you use srun-pty-bash-l, run this on the front end, what will happen is that a job will be created and you will get a connection to the job directly. So you see that here I run this, and then I have to wait some time sometimes, but afterwards I am connected to a compute node where I have a bash session running on the compute node, where I can run the hostname command, for instance, and it shows me here the name of the nodes on which I was allocated a CPU. Okay, srun takes exactly the same set of options as batch and so on, so you can request multiple CPUs, memory, maximum time, and so on. The difference being that you don't give it a script, but you get an interactive bash session. Okay, so if you have small tests to do, or you have some small computations you want to do, and you don't want to submit a job, wait for the answer, and then submit another job, you can request an interactive session. So once you have an interactive session, there are recipes to actually start a Jupyter Lab or Jupyter Hub instance on the compute node, and then have access to that web interface on your laptop. And this is what I described here. So you see here srun-pty. Here I'm requesting 4 CPUs and then bash-l. I have to wait here, but then at some point I am given access to the compute node. And what I first do here is use the module load command that you saw this morning to load some release and Jupyter Lab. Okay. Doing that, I have access to the Jupyter command, and I can run Jupyter Notebook, which is typically what you would run to start Jupyter on your laptop, with here some additional parameter here, --IP, with a command here which takes the IP of the node. And this is important because you wouldn't have to know how to access that Jupyter Lab instance from your laptop. And so basically doing this, what happens is that Jupyter starts and it gives you the URL that you can connect to access the web page. The thing is that URL is only available from the front end, not from your laptop. So you have a bit of work, additional work to do to get access from your laptop to that instance of Jupyter Lab running on a compute node, going through the front end. And that you do with SSH. So you run SSH provided that your SSH client is properly configured, as we've seen in the previous sessions. And then -D, you choose here a number, which will be a port number. You need to choose it more than 1024, but basically you choose it. And then you leave that, you will be connected as if you did not put that information, but behind the scenes, what will happen is that SSH will create what you call a SOC proxy for you to access the compute node through the login node in a transparent way. And so then you have to configure your browser. So here I'm showing the example with Firefox. So in the settings, you look for proxy. And then you choose a SOC proxy, which must be localhost, SOC file. And then you need to specify here the number that you chose earlier. So I decided to use 8787. So I run SSH-D, that number, and I put the same number here. And then you click on OK. This will prevent you from accessing other websites. So if you do that, it's always nice to create a specific profile or use another browser. So for instance, I'm using Safari for going to regular websites, and I'm using Firefox when I need to do this, so that I know Firefox is always correctly configured. The same functionalities exist for Chrome or whatever browser you use. You just need to look for the proxy and SOC 5 options. But then you can go back to the output of Jupyter Lab, and if you put the exact URL that was given, you can put it here on your laptop. And even though your laptop has no direct connection to the compute node, through the SSH session, you will have access to your Jupyter Lab instance. That Jupyter Lab instance will be available as long as you don't kill the Jupyter Lab server that you have started with srun, or as long as the job is running. If you hit the time limit, your job will be killed. Okay, I will skip the RStudio part unless someone is using RStudio. The idea is okay. So with RStudio, the idea is exactly the same. Here is the same, srun-pty-l. There are some differences here in the way the RStudio is launched. So because it's different than Jupyter Lab. So I'm running here R server, which is the server version of RStudio. And then I need to tell it not to daemonize, meaning not going in the background, because we will want to have access to that section. And then I need to give it a port, just like before I chose 8787. Here also you need to decide a number. And then you need to choose which R you will be using. So by default, when you start RStudio, it uses the R version that it finds. But here, if you load some specific R version, not here, but okay, you can choose. I mean, RStudio is different from R, so you can choose the R version inside RStudio, and this is done with this part here. Auth non-zero, and then this is a trick that you will have to go through to make sure that not everyone is able to access your RStudio instance. Because Jupyter Hub, the way it works is it creates a URL which has a unique number in it which cannot be guessed, but it shows you on the screen, so you can just copy it. But with RStudio, you need to enter login and a password, and we don't have login passwords on the CÉCI cluster. So actually, what you have to do, sorry, it was before, is to install a helper script with the wget command that's here. Just run this, it will download the program from the internet. And then you can refer to this program here. And you need to choose a password, like here. And the username will be the username you have on the cluster. Once you have done that, again, the same command in SSH to create the tunnel or the sub proxy, the same configuration in Firefox. And then you get to this page where you put here your CÉCI username and here the password that you chose when you started the RStudio instance. So it's different from the password phrase you chose when you created your CÉCI account. It's a one-time password that you create specifically for this RStudio instance. And then you have your typical RStudio interface. Any question about that? Okay, I will go from front to back. Yes.
Since we already waited in the queue to be able to launch the Jupyter Lab, does it mean that once it's launched, we don't have to wait to run something on the Jupyter Lab?
No. So since you start an interactive session, actually, as soon as the allocation is provided, you have access to the resources. Okay. The thing is, if it's 4 in the morning and you are sleeping, then the allocation just sits either doing nothing until you wake up. It's the problem working interactively on a batch system. You don't get to decide when you get your allocation. And so there are options like --begin to tell Slurm, okay, don't start this job before 8 in the morning because I will be sleeping. But then you kind of lose some priority. Some other jobs could go before yours. So sometimes not easy, but most of the time you do that for jobs that are small in size or in length, because you don't stay in front of your screen for a long time. And so it works well.
Once the interactive session is launched, then it's okay, we have the session open and we don't have to wait.
No, all the resources that you requested are there for you to use. Yes. 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 The idea is that we don't want resources to be sitting doing nothing while you do nothing in between. Okay, so what you can do is at 8 in the morning, you start this, you run something that lasts for a long time in the browser. You can shut down your browser, you can shut down the SSH connection. And then at the evening, you can do the SSH connection again, open the browser again, and then you will have the results. But if you do that a month later, you will not be able to do it again. You will start a Jupyter instance, the RStudio instance. Because the best way is to use R script to submit a batch and not use R through the. Sometimes you need to use the interface if you want to do things, I don't know. But most of the time, everything that you want to do with this, you can do it in the command line with R syntax. And that's the optimal way of using the cluster. Okay, so here I had a section about how to use Maestro, which is a way to not have to write submission script. Just showing you how beautiful the slides are. So skip to the end. Basically, we're stating everything. So the way you work is you write a submission script, you submit it, you get a job ID, and with the job ID, you can monitor your job. You can cancel it. You can do whatever you want. I've shown you how to explore the resources that are offered by the cluster with SInfo, the limits also with the ASAC manager. Do not hesitate to read the man page of the Slurm Commons. Do not go to the Slurm website, because on the Slurm website we have information about the latest version of Slurm. It might not be the version that is installed on the cluster you are using. So the best source of information is the man page on the cluster. Please use the resources that you request. If you request 10,000 cores and you do nothing, it's just electricity that is used to make the climate worse. Beware of the limits. Always try to think, if you find yourself doing something repeatedly, there must be a way to do it automatically. Okay, so have a look at the web page on the workflows. There are tools there to help you. And then do not hesitate to submit jobs. If you see a large amount of jobs in the queue, it's not a reason to not submit a job, because your job might go to the top of the ladder, depending on the priorities and so on.